now. I was staying here. Okay. So, here we go, ladies and gentlemen, boys and girls. We are doing the unit circle. I kind of semi-talked about the unit circle last time. No cheating off of this one. Okay, you learned. That's good for you, because I believe in you. You're a smart girl. You are too. Miss Marie, I believe you are as well. Everybody else has to live up to those people. Okay. Here we go. So once again, this is 0 degrees, correct? How much is a full circle? 360. So in yours, somehow you might want to have 0 to 360, and then you have 2 spots just like up and above, don't you? Okay, what is 0 degrees as radians? 0 radians. What is 360 degrees? 2 pi. We talked about this a little bit, right? Everybody there with me? Well, onward. Okay. Sorry. What's half of a circle? 180. What is half of it in radians? Pi. None of this should be unfamiliar to you so far. Okay? If this is 180, what's half of 180? 90. So therefore, half of pi is pi over 2. Does everybody understand that? What's this guy down here? 270, because we're adding 90 3 times. 90 plus 90 plus 90 is 270. Anybody have a question there? Good job, Micah. 3 pi over 2. Okay? Now, those are some of the things we've already talked about. Once again, the word unit means 1, correct? Okay, so guess what our radius is on the unit circle? 1. So therefore, all these lines are a distance of 1. Now, don't write them on it. But with that being said, what's this distance from this point to this point? 1. Why is it 1, 0? Because I'm over 1, up 0. I'm not moving on my y, am I? Right here, I am not moving on my x's, but I'm moving on my y's, right? So this point up here is 0, 1. Everybody there? This point right here is what? Negative 1, 0. Why? Because that's a distance, correct? What about down here? Not 1, 0. 0, negative 1. Is everybody okay with that? Everybody understanding that? Okay. Any questions up to there? Okay. Anybody got a pen? I need a pen. Pen. Pen it is. Right there. Okay. All right, guys. So once again, this is my little idea here, okay? Here's a circle. I cut it in half. That's 180, right? Cut that in half. How much is that? 90. Doesn't that look like quadrant 1, basically? Right? That shows 90 degrees, correct? Okay, so what we're going to do now is I'm going to cut this guy in half. What is that? So notice right here, I'm going to kind of use his pen, and notice I have a line here, and I'm going to put this tick mark right on this edge here. Okay? Sorry. Okay, so as you said, it was 45, right? Can everybody see this little tick mark here? And there's not one up there. Let's convert this logo up. Maybe a Sharpie, yeah, would be good. So as I open this up, 1, 2, 3, 4. I have 4 things that are 45 degrees, or there's 4 reference angles of 45 degrees, huh? Does that make sense to everybody? Okay, so therefore, I have this. I'm going to go ahead and say, okay, what is this degree measurement? 45, because that is a 45 degree reference angle, correct? isn't that half of 90? Right? That's half of 90. Is that better? I'm not very good at this. So therefore, if I take a half of pi half, what is it in radians? Pi fourth. Does everybody see the pi fourth? That's pi fourth. So the half of a half is a quarter, right? If you have 50 cents, you cut that in half, that's 25 cents, which is a quarter of a dollar. A quarter. I know I'm smart. Okay, so notice this is also 45-degree angles, right? So what is this angle from here to here? 135, because I got to cut back 45 degrees from 180, correct? So this is 135. Well, isn't pi 4 pi fourths? Like times 4 top and bottom, right? So I'm going to cut back 45 degrees, which is just cut me back pi fourths. Does everybody see that? So using my reference angle, that's basically what I'm trying to understand here, correct? That this guy is pi fourths. Not pi fourths, well, silly rabbit, 3 pi fourths. Does everybody understand why it's 3 pi fourths? Because I had 4 pi fourths cut back to pi fourths. Or, let me teach you this way. Notice I have pi fourths plus pi fourths is 2 pi fourths, right? If I reduce that, 2 pi fourths is pi half. 2 pi fourths plus 45 is 135, which is 3 pi fourths. 3 pi fourths plus pi fourths is 4 pi fourths. Basically, I'm counting, huh? If he's 4 pi fourths, what's this guy? 5 pi fourths. And notice that's adding 45, which is 225. Does everybody understand that? You okay with me now, partner? So if I add 45 again, that's 270, or 5 pi fourths plus pi fourths, that is 6 pi fourths, which reduces down to the 3 pi half. This guy right here would be 7 pi fourths. Good. And notice that's 315 degrees. Notice they all have the same reference angle, don't they? Okay? And then notice if I add 45 again on that, 8 pi fourths, which is 2 pi. I went around the whole circle. Does that make sense? Okay. Now, how do I get its coordinates? How do I get its coordinates? Well, you guys remember yesterday how I showed you the special triangle? Okay? This is 45 degrees. That was our reference angle, huh? What's this up here then? 45, and this is 90. So it's 45, 45, 90-degree triangle. Right, Juan? Okay. So, remember, what's our radius? 1. Notice, so therefore, it's on that special triangle I showed you last time. This is root 2 over 2, root 2 over 2. Did everybody see that? So what is this coordinate right here? If this was 0, 0. Because I am over root 2 over 2, right? And I'm up root 2 over 2. Does everybody understand where that coordinate comes from? Right? Okay. So this coordinate is root 2 over 2, root 2 over 2. You have a question there? Hello? Hello? Let's try to find a good spot for it. That's a good spot for it. Okay. We're going to leave that with me. I'm just going to fill out this coordinate, and then we're going to work to get the other coordinates down here. Okay. Well, let's actually talk about that now. Okay? So once again, this point and this point, because a circle is symmetrical, land right on the same spot, don't they? And that should make sense as well because they have the same reference angle, correct? So what's this coordinate right here? Why is it negative root 2 over 2? This guy wasn't negative. You're right, but tell me why. Because I'm over x, up y. So is it the y value positive or negative? Positive because he's up, huh? Does everybody understand how I got this symmetrical about the y-axis. These guys are the only ones that are symmetrical because I pulled it out this way. So notice these points flip down to the other guys, don't they? So this coordinate down here would be what? Negative root 2 over 2, comma, negative root 2 over 2, and once again I explain why they're both negative. These went over left and then down, right? Does everybody understand where that's coming from? Miss Bacon, you okay? Okay. What's this coordinate right here as well? Root 2 over 2, comma, negative. Does that make sense, Marco? Marco, I'm telling you. Okay. Does everybody understand how I found those? Well, once again, ladies and gentlemen, what's this again? 90. Instead of cutting in half, I can cut it into thirds. What's a third of 90? 30. So therefore, this guy is 30 degrees. Now notice this angle up here isn't 30 degrees. This is really our 30 degrees. Right? You guys understand that? The reference angle is 30 degrees. Okay, so if he's 30 degrees, that was a third of 90. So what's a third of pi half? Pi 6. Good job, Micah. Pi 6. Does everybody understand why that's pi 6? Okay. Notice, therefore, that means this guy is 30 degrees away from 180. So what's his angle? 150. Do you see that? How it's just cutting back the reference angle? This was 6 pi 6, and I'm cutting back 30, which is pi 6. So what's this guy? 5 pi 6. This angle is 30 degrees plus, so that's 30 degrees plus 180, right, which is 210. Does everybody understand why 210 is there? Because we're adding 30. So what do you have there? Go, Mikey, go. Why? Because you got 6 pi 6 plus a pi 6, huh? Checking around. Is everybody good? 7 pi 6. And technically, you remember how we actually learned how to convert degrees to radians? Could you check it if you needed to? You could. How far is this angle away? 30, right? So this would be 360 cut back 30, which is 330. Does everybody understand where 330 comes from? Right? And then, that's 12 pi 6. Cut back pi 6, so this is 11 pi 6. You guys understand where the 12 pi 6 came in from? The whole circle is 2 pi, which is 12 pi 6, right? Everybody with me there? So notice, remember, that's when we have the triangle of 30, 60, 90. What's our radius again? Because it's on the unit circle. 1. Right? And what's the guy opposite 30? A half. What's the guy opposite 60? This was from the last time, correct? So if you don't quite understand that, that's from last time's lesson, right? The special triangles with our radius being 1. Okay. So what is this coordinate right here? Root 3 over 2, comma, a half. And then once again, we understand this guy is root 3 over 2, comma, half. I would like you to fill this with that. Recording! So once again, how I got this was because of pi thirds, and we just basically found them, but notice it's just doubling 120 to get to 240, so that's doubling 2 pi thirds to 4 pi thirds, right? How does 60 get to 300? That's multiplying by 5, so that's 5 pi thirds, right? Breaker, we're back with us. excited? Okay, so now we're going to run with the 60-degree triangle. Okay, but haven't we already done this triangle? Right there. We just need to flip it, don't we? So it's like this. 60, 1, root 3 over 2, 30, and 1 half. So what's this coordinate? 1 half, comma, root 3 over 2. So, Sherry, I caught myself. But I caught myself, did I not?
No, you did. Try to not.
So, this guy is 1 half, comma, root 3 over 2. So what? Fill out the unit circle for me, knowing about its reflecting over the x and y axis. Right, Rochelle? It is 1 half, comma, root 3 over 2. Does that make sense where that came from? Are any of you guys a little bit nervous about memorizing this? Give me a hand if you do, you think. How many of you guys know how to count? Good. I know how to count. Okay? If you know how to count, you know how to do the unit circle. Well, if you know the triangle, it's really easy as well. But notice, if you know this quadrant, don't you know the whole thing? Okay, so we need to know how to do this quadrant. Okay? With that being said, notice, isn't 1 the same thing as 2 over 2? And isn't 2 the same thing as root 4 over 2? Get ready to count. Root 4, root 3, root 2, root 1, root 0. Look how they're all over 2, right? Need to have you do the mountain problem. I will hurry draw it. Are you ready for the mountain problem? That's the height of it, not the light, okay? He's looking up 3.5, that's 3.5. You don't know that distance, so that's why it's not. There we go. Okay. Look at this. We gotta figure this out. Okay, so. Huh? Hello? No. You're gonna have to hold it. Anyway, once again, let's count again. So notice, see how all of them are over 2. Well, isn't 0 over 2 anything? Because then 0 over 2 is still 0, right? So you could imagine they're all over 2. That kind of looks awkward. All right, with that being said, notice this is 1, which is square root of 4 over 2. Square root of 3 over 2. Square root of 2 over 2. Isn't it 1 square root of 1 over 2? Square root of 0 over 2. Or you can go backwards. Square root of 4, square root of 3, square root of 2, square root of 1, square root of 0. It's all about counting. Dun, dun, dun! Did you do it? It's all about counting. Now, why did I just make you do this? Well, I do want you to memorize it. But look at number 4 of the bell quiz. Everybody has their unit circles, right? First off, what did I tell you yesterday? What is sine of theta? It was y over r. Remember how I told you it's the y value over the radius? What's our radius on the unit circle? 1. So isn't that just y? So if I said, what is the sine of 225? Go to 225 for me now. Go! Find the y value. What is it? No. Negative root 2 over 2. There's your answer. Isn't that pretty cool? Isn't that a lot simpler? Right? Because all these angles have the same well, not the same reference. They don't all have the same reference angle. Because these guys, in general, will have a reference angle that is shared over and over and over again. So it's the same coordinate over and over and over again, right? Okay, that was fun. Anyway, so now I said, dun dun dun, go to the cosine of 720 degrees. Is that on our inner circle? Yes, but no. Right? Because notice 720, we're like, there's 360, there's 360, so it's coterminal to 360 and 0, isn't it? Then we look at the coordinate at 0 and 360. What's the coordinate? 1, 0, and cosine is the x value. Remember, alphabetical order. Cosine goes with x, sine goes with y, right? So notice, what is the cosine of 720? 1. Any questions? That is your homework.